So, Chapter 11, Section 7, we're looking at partial fractions. Now this bit is really simple for me to explain, not necessarily simple to do, but it works like this. If we have something that looks like this, integral of x minus 5 over x plus 1, x minus 2, with respect to x. Basically, we can't integrate it, right? We don't have a particular method for integrating something that looks like that, but if we have something that looks like this, just one moment, if we have something that looks like this, integral of 2 over x plus 1 minus 1 over x minus 2 with respect to x, we do have a way to integrate that, because that is 2 times the natural log of mod of x plus 1. Okay, if you differentiate that, you know, this is 1 over x, but it's a linear function in x instead of being just an x. Well, we can deal with that. It's natural log of that divided by the coefficient of the x, which is 1. So that's that. And the same logic gives us this. So I can't integrate that, but I can integrate that. But guess what? If I take that thing and partial fraction it, I get this thing. So this whole section just says if the thing in the integral can be partial fractioned, you might want to partial fraction it and work from there. And that's really it, right? Once you've partial fractioned, you will be able to integrate the thing that you've got. I'll just show you one more quick example, which is part B, which is, so we start off with some mess when we've partial fractioned it, and I'm not going over the partial fractions, by the way, because the partial fractions, there is a whole video on partial fractions earlier on in the same playlist. If you didn't find this video through the playlist, then nip to my channel, look for the playlists, and there is a playlist covering, well, hopefully soon it'll be covering all of the year 2 pure. So when we partial fraction, we get this. This one we can integrate as 2 natural log of mod of 2x plus 1 divided by the coefficient of the x, and we get, well, 2 times a half, so we just get that. This one is x minus 2 to the power of minus 2, isn't it? So we're going to have x minus 2 to the power of minus 1 divided by the new power, so that's divided by minus 1, so that minus sign there becomes a plus sign, so 1 over x minus 2, divide by the coefficient of the x, because this is the linear term in x, but the coefficient of the x is just a 1, so we get that. And then this one here, when we integrate that, we get 3 natural log mod x minus 2. And then don't forget the constant of integration. Now, with this sort of thing, and with this sort of thing, we haven't really finished, because we can use our power rules and we can use our, what do we call them, division rule for mods. And we can do the same thing here with this bit and this bit. We can bring the 3 up here. So we end up with natural log of mod of 2x plus 1. Now this isn't a division rule because there's not a minus there. There's an add there. Do we call it a division rule or an addition rule? I can't remember. A division rule or a subtraction rule, but it doesn't matter. There we go. Plus 1 over x minus 2 plus c. So we can tidy up any natural log bits that we get. In example 21 on page 311, we get a harder partial fraction to do, but again, it's just a partial fraction. Once we've partial fractioned, then we can do the integration. Okay? The integral becomes this thing, and that thing there becomes this thing here when it's partial fractioned. Before we could do the partial fraction, we needed to do a polynomial division. And again, I'm not going to go through that. It's all the techniques for doing those things are in earlier chapters. So that the only thing we've got to say is partial fraction or polynomial division and then partial fraction. And whenever you've done that, once you've finished, the thing you've got is something you can now integrate. So that section is just saying, can you do well all the partial fraction stuff, all the integration stuff from the chapter so far? And if you can, you're sorted. Good luck with 11G.